So this is going to be part 2 of our notes on thermodynamics. It is about finding C, and question number 6 says a metal was dropped into a calorimeter with 150 grams of water. So we know that this is our M. And the water changed in temperature by 3 degrees. So this is our delta T. And the heat exchange was calculated as 554 joules. So that is our Q. Find the specific heat capacity of the metal and state the identity of the unknown metal. Once again, we're going to use the equation Q is equal to mc delta T, and in this case, we're going to put down for our Q 554. Our M is 150. Our C, that's the one we're solving for, and our delta T is 3. So after we do that, we plug in everything into the equation. We get our C is equal to 1.23. So that means that sodium is the unknown metal that we're looking at here, because this 1.23 matches the answer that we got here, so it means that the unknown metal is sodium. And do not forget to put down your units over here, so it's J over G over C. The next question that we have is number 7, and it says a silver coin was purchased from a pawn shop. To be sure it's really a silver coin. We weighed it at 28 grams and heated it to 100 degrees Celsius before dropping it into water. And the water itself weighed 288 grams. The water was at 23 initially before it was dropped, and then it rose at 27 degrees after the coin was dropped. Is this coin really made of silver? So we are going to put down our Q of water will equal the Q of the metal. And in this equation here, we are going to put down mc delta T is equal to mc delta T. But in this case, we're going to put M of water, C of water, and delta T of water is equal to M of metal, C of metal, and delta T of metal. So the silver coin itself, or what we suppose is silver, weighed 28 grams. So this is our mass of the metal. And we heated it to 100 degrees Celsius before dropping it. So 100 degrees is our initial temperature of the metal. And 27 degrees is our final temperature for both the metal and the water. So we're going to put 27 minus 100. And we don't know the C of the metal. We don't know if this is actually silver or not, so we're just going to put C over here. The mass of the water is 288. So we're going to put 288 as our mass of water. The C of water is, let's go back to the chart, it is 4.18 for water. And the delta T of the water is going to be 27 minus 23. So then if you plug in all of this into the calculator using menu 3.1, you will get what the C value is for this metal. So then after we do all of that in the calculator, we see that we will get If we press enter, we get negative 2.35 as our C value. So we're just going to change it to positive 2.35 C, J over G over C. So because our answer was 2.35, this is not silver, because silver is 0.235. So the answer is no, this is not silver. So it is not silver. Next is question number 8. Because we are going to find C, we have to automatically do this. So we have to put down this automatically. Q of water is equal to Q of metal, M water, C water, delta T water, M metal, C metal, and delta T metal. And then we're just going to be ready to start plugging in stuff into the equation as I read the question. So question 9, or number 8, says an unknown metal was dropped into the water container with 226 grams of water. So the water itself weighs 226. So we're going to put that over here. The water rose in temperature from 19 to 24. So this is our final temperature of water, and this is our initial temperature of water. So we're going to put down 24 minus 19. The C of water is 4.18. We should already know that. There's no need to go to the charts for it. But if you need the chart, here it is. 4.18 is for water. Next is we're going to find the mass of the metal. The mass of the metal is 40 grams, so we're going to put 40 grams right here. The initial temperature of the metal was 84, so we're going to put down 84 as our initial temperature. And of course, the final temperature of the metal is the same one as the water's final temperature, so it's 24. So we're going to put 24 minus 84. And excuse that mistake over there. We don't know the C of the metal because, again, we are trying to find out the identity of the unknown metal. So we do not know its specific heat yet. So just like the last question, we're going to plug this all into the calculator using menu 3.1 to find the C of the metal. So the specific heat capacity turns out to be 1.96. Ignore the negative. It is irrelevant here. And of course, the specific heat capacity of the metal, it is not on your charts. There is nothing on your chart that says 1.96 or is even close to that. Next is question number 9. Since we are looking to foresee, once again, we are going to use this equation. So we are going to use this equation right here. I skipped the setting it up, just write it down. So just write down this equation, and then we could look at the question. So the question 9 says, I stumbled upon some gold rocks. To test whether these rocks are truly gold, I weigh them as 50 grams before heating them to 98 degrees Celsius. So right away, we know that the metal itself weighs 50 grams. Our initial temperature is 98 for the metal, so we are going to put that right here, minus 98. Before dropping them into a water container with 200 grams of water. So the mass of the water is 200. The initial temperature of the water was 25 degrees Celsius. So we are going to put that as minus 25 here. Before and 29 degrees Celsius after the gold was dropped. So 29 is your initial temperature of the water. And we know that 29 degrees Celsius is also your final temperature of the metal, so it's going to go here. So 29 goes both here and here because it's the final temperature, and it will go first on both of them because it's final minus initial, final minus initial. We don't know the C of the metal. And we know the C of the water is 4.18 because according to your chart, water is 4.18. So now that we've finished setting it up, we're going to put all of this into the calculator to see if the C will equal that of gold, which is equal to 0.129. Right here on this table, we see that gold has a 0.129 C. The question is, does the C equal 0.129? Let's see if it does. So the C is equal to 0.96. So these are not real gold rocks because it does not match the C of 0.129. So the answer is no, they are not real gold rocks. So it is not gold. Okay, so for number 10, the answer is going to be yes, you always measure the temperature before you mix the two. Otherwise, you don't have a delta T that you could use to find anything for the experiments. And then for number 11, yes, to figure that one out, you have to dump the heated metal using tongs, and then you place a thermometer inside the beaker with both the metal and the water inside. Number 12, the delta T of the water is going to be, this is our initial temperature and this is our final temperature. We're going to plug in final minus initial, 32 minus 24, and we get 8. So the delta T of the water is 8. The delta T of the metal is, this is our initial temperature, and this is our final temperature. So it's final minus initial, 32 minus 98. So it is 66. So the delta T of your metal is 66, and the one of water is 8 degrees Celsius. Then we have, of course, these are the solutions for questions 13 to 14 and 15, and I'm going to explain why this is the case right now. So we placed a beaker on the scale right here, and it says 200 grams. But does that mean that we have 200 grams of water? Well, the answer is no, because if we dump the water out, we could see that the beaker itself weighs 111 grams. So that is a problem when you're doing the labs. So to fix it, there's just this little button over here called the tare, and it resets the balance for you. So make sure you click this button right here, and it will reset it for you. So now I can get 200 grams of water in here, and I'll be sure that it is actually pure water because I clicked this button for that reason. So when you're doing your labs, make sure that you either click this button with an empty beaker on it, or you measure the mass of your beaker before you do any other experiments on it.